G'day folks, welcome to another tutorial. Wait a minute, there we go. Okay, so we got a few little things to go through today. What I really wanted to talk about was if statements, but we'll go through using namespace statements and reading numbers from the keyboard as well, since we can't really do anything without reading stuff from the keyboard. Yeah, okay, so using namespace std, I put this at the top of my final example from the previous tube. I think I did anyway, just to force a habit. But all this means is that instead of having to type std : cout and std : endl, end line, or indeed std : cn, we can just say cout, like that. And Visual Studio will assume that we're talking about std : cout. Alrighty, so you can just put that at the top of your file. And we'll do this at the end of the tube too, in another little example. But that's all that means. Okay, so reading stuff from the console is pretty easy. To write to the console we use cout, and to read from the console we use kin. We also use the extraction operator, which is two greater than symbols, no space in between. And just as the, what was the other one? Insertion operator, which is two less than symbols. We put this after a cin, and what this is going to do is read a value from the keyboard that we type, and it's going to store whatever we type into my variable. So my variable just here would be something that we've declared, either an integer or a float or a double, whatever it is. And cin is going to read what we type at the keyboard and store that in the variable my variable. Okay, good stuff. But this is the real crux of the tutorial here. This is the conditional operators. So we've got a whole bunch here. And, well, let's just go through them. We've got, first of all, the double equals, two equal symbols, one after another, means is equal to. Not equal to is an exclamation point and then the equal sign. I'm not real sure where the exclamation point came from, but it means not in a lot of programming languages. Yeah, so not equal to, that is, literally. We've got greater than, less than, or greater than or equals to, or less than or equals to. So those are, that's pretty much all of the conditional operators. They just test if a certain number is, equal to or greater than or less than. But probably the most important thing to note is the double equals as opposed to the single equals. So the double equals that we're looking at here is a conditional operator that's asking if one thing is equal to another. The single equals to actually is the assignment operator, and that assigns a value to a variable. So if we had a equals b, it's going to put the value that's in b into the variable a. Whereas if we have a double equals b, then it's asking, does the value in a equal the value in b? Really, really important not to confuse the two. Yeah. Okay, so what do they do? All of these operators return a Boolean value, bool, either true or false, that is, or yes or no. It actually returns 0 or some other value. But that evaluates to true or false. So for instance, we've got 25 less than 45. That's going to return true. 100 double equals 23. In other words, that's asking, does the value 100 equal the value 23? It obviously doesn't. 100 equals 100. Doesn't equal 23. So that's going to return false. Or another example here, we've got 99.5 does not equal negative 2.2. Obviously 99.5 is not negative 2.2, they're two different values, so that's going to return true. Okay, stupid examples, but anyway. This is how we use them, really. You don't usually just sort of stick them in your code. It's not going to do very much if you just put 99 equals 3. It'd be strange. We usually use them with if statements, or something similar. And the if statement allows us to define conditions to execute or skip certain parts of our code. Okay, so sometimes you want to just execute one line after another, But other times, based on certain conditions, you might want to skip chunks of code. You know, if the user types something, or if they click on a particular button, maybe you want to, I don't know, skip some code. Why not? So this is the basic syntax of an if statement just here. This is just a hopeless example. That doesn't mean anything, but if bool, so the bool just here is a condition, then we do something, pretty much. So if a condition is met, then do something. That's all I meant by that. So the bool in the brackets just back there was anything that evaluates to either true or false. This almost always means that you're using a conditional operator, one of the ones that we looked at just a minute ago. So we could say something like if A is less than 23, or if B does not equal A, so two variables just here. These are variables, these A's and B's just here. Probably should have said somewhere. Or we can make complicated expressions, so long as they evaluate to a Boolean value. So just here I've got if C multiplied by 4, and C is a variable, maybe an int or a double, a float, it could be anything. But if C multiplied by 4 is less than, and now I've got in brackets 180 over 2 plus my var. So my var would also be a variable in this instance. And the computer's just going to figure that out. It's just going to ask, is C multiplied by 4? Whatever C is, it's going to multiply it by 4, then it's going to figure out what the right-hand side here is, and it's going to decide if that's less than, or greater than, or equal to the left-hand side, and it's going to execute the following statement based on whatever it figures out. Pretty good. Okay, yeah, I mentioned this before, but I'm going to mention it again. The single equals is not a condition. If Q equals 3, strangely enough, is always going to execute. It's just going to say, what's going to happen is the equals just here, a single equals, is the assignment operator. So 3 is going to get stored in the variable Q, and C++ uses the value 0 to mean false, and anything else to mean true. So what's going to happen is it's going to go if 3, which is not 0, and it's just going to say, well, that's true. Not 0 is true. 3 is true. If we said if Q equals 0, and we used 1 equals like this, then it would never execute. That would always be false. But look, the point is that a single equals is not what we're after. That's not a condition. That's an assignment. So what we really mean here is double equals. If Q is equal to 3. Okay, it's a trap. Just be careful. Be careful. Alrighty, if statements. Here we go. Executing a single statement after an if condition. On the previous examples we just had an if statement, which doesn't really do anything, and this is more what we're after. So if I double equals 0, and I is a variable here, then cout or print to the screen I is 0 and all. And this line just here, cout I is 0, will only execute, so we'll only get I is 0 printed to the screen if the value in I is actually 0 when the computer reads that line. Fair enough? Pretty easy, really. Some people prefer to have the statement to execute on another line. So you'll see this quite often. You'll see if I double equals 0, and then enter for a new line, and this is tabbed across one space. Yeah, cout I is 0. It's up to you. Whichever you prefer. You can also add a code block. So instead of having just a single line like we did on the previous slide, you can actually open up a code block, just as we've got here. So if I double equals 0, and the very first thing that I've got is an open brace, and the closing brace is down here, I've only got comments in the body of the code block at the moment, but anything inside those braces is going to execute only if I equals 0. Otherwise, the computer will jump right down to just below the closing curly brace there and start executing from there. So this code here would be skipped if the condition is false. You'll also see really often this curly brace here either not tabbed across. A lot of people put them over the far left hand side here, Or another really common thing is to put the curly brace just beside the condition up here. I don't know. Up to you. Okay, so else if and else. These are pretty cool actually. These make things much more flexible. So you can design alternative routes for your program using if, else if, and else. The if is always first, and you follow the if by as many else ifs as you like, as many as you need. And finally you can finish, if you like, with an else. If, else, if, else, if, else, if, else. What am I talking about? Else if and else translate pretty much exactly to the English word otherwise. So we say if a certain condition, then do this stuff. Otherwise, do something else. Okay, but instead of the word otherwise, in C++ we use else if and else. Presumably just because it's quicker to type. Yeah, else is a shorter word than otherwise. Anyway, you get really used to that. If you use a final else, it does not have a condition. Yeah, so if and else if, they have conditions in brackets after them, like we saw the condition with if statements. But the final else doesn't have a condition. It always executes. And only one of these executes as well. So if you've got a bunch of, if you've got an if, a bunch of else ifs, and then a final else, only one code block from one of them will execute, and the others won't. Yeah, we'll see that. We'll see that just here. Here's a bit of an example of how they all look. So here we've got one if, and it's got two else ifs, and a final else. So what's going to happen here is the computer's going to go if option. So option is my variable just here. That's a variable. Maybe an int defined somewhere else. If option double equals 1, so if the value in option is currently 1, then we're going to execute this line just here, and we're going to write to the screen that the user typed 1. Else if, so otherwise, or in other words, if option isn't 1, if option double equals 2, then we're going to say typed 2, and we're going to print out A for some reason. Oh, what a stupid example. Yeah, I don't know what that A is doing there. I meant to just say typed 2. Yeah, but the important thing to note is that if the first one executes, so if option happens to equal 1, then the else if down here isn't even going to be checked. These three remaining else's are all just going to be ignored. Alrighty, so I would say typed 1, and then it would jump straight out of the whole, whole block. Anyway, so if the first two options are false, or in other words, if option isn't 1 and option isn't 2, then it's going to check, and only then, it's going to check if option happens to be 3, and if it is, it's going to print A again for some reason, whatever A is, then typed 3. Alrighty, and finally, if none of those things happen, so if option's not 1, if it's not 2, and if it's not 3, if it's something else, maybe it's 4, or maybe it's 0, or a negative number, then this is always going to execute. So finally, we're going to say typed something else at the end. Alrighty, so that's pretty basic, and that's a fairly similar pattern to what we'll be programming at the end in an example, without the, yeah, whatever. Okay, so this is where things get interesting again. Programming's full of interesting things. Double ampersand and the double pipe. These mean and or, respectively. And these are used to combine together the conditions or the Boolean expressions to form more complex conditions. So for example, we can say if A double equals 99 or, the two pipes, B double equals 23. So the next statement after that is going to execute if either of the two is true. Alrighty, so if A is 99, it's going to execute. Or if B is 23, it's going to execute. If both of those conditions is false, the statement's not going to execute. But if one of them is true, or if both of them are true, then it's going to execute. So that's interesting actually too, and that's again another departure from the way English works. the OR just here will execute if they're both true. Usually you say, you know, you can have apples or oranges. And in English, you would mean that you can't have both. You know, you can have apples or oranges, means that you're either going to get one or the other. But in C++, it's a little different. So if A equals 99 is true, and if B equals 23 is true, you know, if they're both true, then it's going to execute. Good, that's confusing. The next one, I just got a bit sort of carried away, and yeah, this is what I come up with. So my var just here is another variable. A and B were variables also. I should specify somewhere that these things are variables. Anyway, my var is a variable, and this one is if my var is less than 89, or, and then I've got some more conditions in brackets here. So, or if t is greater than 66 and t is less than 100. So this condition here in brackets is its own sort of condition, and that sort of means, what's it going to mean? If t is between, say, 67 and 99 inclusive, yeah, that's all that means. Yeah, if t is greater than 66 and it's less than 100, then that's where it is. It's between those two values, 67 and 99. So the computer's going to figure out if my var is less than 89, and if it is, then you know, the statement following the if statement is going to execute. Or, as an alternative, if that's not necessarily true, it's going to check this one and see if t is between those two values. And if t is between those two values, or if t is greater than 66 and it's less than 100, then it's going to execute the statement as well. And only if both of these two, both t being in between, you know, those two values, and my var being greater than or equal to 89, if they're both false, then the statement's not going to execute. Alright, fair enough. So the second example, yeah, this is weird actually. It takes a bit of getting used to, but it's not too bad. So in the second example, we had to say the t twice. T and t. So this is different again from English. In English, you could just say if t is greater than 66 and less than 100. But in programming, you have to say the t twice. So if t is greater than 6 and t is less than 100. Alrighty, so the computer's not smart enough to know if you just say if t is greater than 66 and less than 100. The computer won't be smart enough to know that you mean t again the second time. You actually have to specify it. Yeah, okay, what was that line thing? So the pipe, this is, yeah, the pipe is just the, on my keyboard it's just below the backspace key. Yeah, it's called a pipe, above the enter key. I don't know, have a look, you'll find it. You might have used it before. The pipe. So that's OR. I don't know why they call it OR, a double pipe, but anyway. Okay, so nesting if statements is placing one inside the code block of another. Yeah, we looked at how you can make code blocks for if statements, and you can actually nest other if statements with their own else's and their own else ifs inside the code blocks of others. And there's really no limit to how deeply you can nest them, so we could have more nested ifs inside these nested ifs, inside nested ifs, inside nested ifs. Yeah, I think there's no limit. There used to be a limit, but I think it's gone. Pretty much. We've got so much RAM in computers nowadays. Anyway, this is a nested if statement. So we've got here, if I does not equal 0, and straight after that I've opened up the code block for that condition. And this opening curly brace here, its partner, its matching pair is right down the bottom. This one down here. So if I does not equal 0, and we open up a code block, and the first thing we've got inside the code block is another if statement. If I is less than 2321. And that's got its own code block. Open and close curly brackets. So the code inside there will only execute if I does not equal 0, which is from the first condition. You know, if the first condition is false, it's going to jump straight down to the bottom down here, outside the curly braces altogether. Okay, so assuming the first condition is true, I is not 0, but I is less than 2321, so that's this second condition just here, 2321. Yeah, that's when this code here will execute. Otherwise, we come down here to this else. So this else just here is nested as well. It's still inside the if I does not equal 0. So we know when we're here that I doesn't equal 0. Also, we know that since only one if and else executes at a time, we know that I must be greater than or equal to 2321 by the time we get to here. Is that fair enough? So it might be a little confusing to think that, I say that only one if and else if executes. But just here we've got an if, and an else executing. But this if just here is not nested on the same level as this else or this if just here. So only one executes on the same level. Does that make sense? Yeah, I think so. Okay, and that's the end of the presentation. So let's get to coding, shall we? I thought I'd make a little calculator. Just to go through what we've been through. So I've set up just a, a basic C++ file just here. And we're going to make a cool little calculator that adds, subtracts, divides, and multiplies. Okay, so the first thing I've done here should be pretty easy. We've just declared 3 integer variables, one called A, one called B, and one called option. So I might go see that. Okay, give us a number. A. Okay, so the first thing we want to do is grab a number from the user, from the keyboard, and we're going to store that into the variable A. And then we'll get another one, and we'll store that in the variable B. Select and option. Okay, now we're just going to present the user with a little menu to ask them what they want to do. Add, subtract, divide, or multiply. Let me just copy that. Okay, so we give them a little menu with these 4 options, 1, 2, 3, 4, and whatever they type we're going to store into the third variable that we declared at the top, which was called option, and then we're going to act accordingly. So here's where we'll have our if statements. What we want to say first of all is if the user typed 1 as their option, we want to add the variables A and B together and tell the user what the result is. So if option double equals 1, so if the user typed 1, okay, if the user typed 1, and then we've got a whole bunch of variables and things to print out, but basically this is just going to print out the first number they typed plus the second number they typed, and then an equals, and then it's actually going to perform the addition and give us the answer. Alrighty, so if they typed 1, we tell them what the answer is. Else if option equals 2, might as well just copy this. Oops. Okay, so if they didn't type 1, maybe they typed 2, which means that they want to subtract the value B from the value A. So this time we want to change these to, the minus symbol, subtract, just like that. So if they want to subtract, we tell them what the answer is. I might just copy this and paste it again another 2 times. We've got 3 and 4. So if they typed 3 or if they typed option number 4, what we want to do is multiply or divide. Just like that. Okay, so that should be our little program. I hope that makes sense. Maybe if I put these on the next lines, our little calculator should be ready to run. Let's actually just put a breakpoint right here. If you click on the left-hand margin just here, you'll see a little red circle, and that's called a breakpoint. When the program reaches this line, it's going to stop, and it's not going to close the window straight away. Anyway, we'll click play and we'll test our program out. Okay, give us a number. Let's say 23. And another number, we'll say 5. And what do we want to do? We want to add them together. So we'll select 1. And there we go, 23 plus 25 is 28. And we'll click stop. And we'll run it again. This time we'll try minus. Let's type 100 and 34 and 2 for subtract. 100 minus 34 is 66. Good stuff. Okay, so we could do multiply, but let's get on to divide because this is cooler. You might have heard, but 23, 0, 4. What's going to happen? 23 divided by 0, what does that equal? Funny. Division by 0 error. I don't know what the answer is. Yeah, you can't divide by 0 with a computer. But we might use that little bug just there. Yeah, in a little demonstration. Okay, so if they've chosen divide, we want to do something else. So we're going to open up a code block. First of all, we want to say if b equals 0. So if they're trying to divide by 0, alrighty, what do we want to do? We want to print out sausage. It's a sausage. Else, we'll just do the divide. Okay, so we can't divide by 0. We might as well just print something out. Okay, so that gets rid of the division by 0 error, but there is something else that we're doing, and if we go F5 and we run it, if we type 4 and 5, then we can just type whatever we want just there, and we don't want that either. You know, we want the user to type either 1, 2, 3, or 4, so we might just put right at the end here a final else, and we'll just say maybe yeah, just some error message to let them know that we care. Anyway, so that's just a little example there of how to use if, else if, and else. And I hope that was helpful, and thank you for listening. See ya.